Capacitors are energy-storing devices available in many sizes and shapes. It consists of two plates of conducting material, usually a thin metal sandwiched between an insulator made of ceramic, film, glass, or other materials, even air. The capacitor is a component which has the ability or capacity to store energy in the form of an electrical charge, producing a potential difference or static voltage across its plates, much like a small rechargeable battery. A capacitor collects energy or voltage as current flows through an electrical circuit. Both plates hold equal charges, and as the positive plate collects a charge, an equal charge flows off the negative plate. When the circuit is switched off, a capacitor retains the energy it has gathered, though slight leakage usually occurs.
Hi, I'm Joshua Daniel B. Casco, and at this juncture, I will present to you the objectives, materials, the diagram, and the procedures that we use in our laboratory experiment. The objectives of this laboratory experiment is to determine the effects of the voltage of the battery, area of the plate, and distance of separations of the plate to the value of the charge and capacitance in a parallel plate capacitor. The materials that was being used in this experiment is the PhET Simulator Capacitor Lab Basic. As you can see in the diagram that we are presenting, this is how the PhET Simulator Capacitor Law Basic works. For the information of everybody, the generalized equation for capacitance is C equals Q over V, where Q stands for charge and the V stands for voltage. In our procedure for the trial A, we increase the plate area while maintaining the distance of separation. As such, there was corresponding increase in the charge, which also means that the capacitance also increased. This is shown in the equation for capacitance, as capacitance and charge are directly proportional to each other. For trial B, we increase the distance of separation while maintaining the plate area. This increases the voltage, as this would increase the resistance. As such, there was a corresponding decrease in the charge, which also means that the capacitance has decreased. This is shown in the equation for capacitance, as capacitance and voltage are inversely proportional to each other. That's all. Thank you.
Hi, I'm Quincy Mary and Clarito. On this stage, I will discuss to you the table A and B, which shows the data we gathered on this experiment. For the table A, the voltage in the battery requires 0.45 volts, while the distance is 3 millimeters of separation, which is held constant. As the area of the plate increases from 150 millimeters squared, 200 millimeters squared, 250 millimeters squared, 300 millimeters squared, and 400 millimeters squared, the results for the charge in the plate and the value of the capacitance is also increasing. The charge in the plate increases from 0.20 picocoulombs to 0.27 picocoulombs to 0.33 picocoulombs, followed by 0.40 picocoulombs, and lastly to 0.53 picocoulombs. For the value of the capacitance increases from 0.44 picofarads to 0.59 picofarads and to 0.74 picofarads, followed by 0.89 picofarads and to 1.18 picofarads. For the table B, the voltage in the battery requires 1.2 volts, while the area of 200 mm squared of the plate which is held constant. As the area of the plate remains constant and the distance of separation increases from 6.00 mm to 7.00 mm to 8.00 mm to 9.00 mm and lastly to 10.00 mm. The results of the charge in the plate and the value of the capacitance is decreasing. The charge in the plate decreases from 0.35 picocoulombs to 0.30 picocoulombs to 0.27 picocoulombs, followed by 0.24 picocoulombs, and lastly to 0.21 picocoulombs. For the value of the capacitance decreases from 0.30 picofarads to 0.25 picofarads to 0.22 picofarads, followed by 0.20 picofarads, and lastly to 0.18 picofarads. For further understanding, we will present to you our Table A and Table B.
At this moment in our discussion, stated that the capacitance is the ability of a component or circuit to collect and store energy in the form of electrical charges. The capacitors are sometimes called the condensers in the automotives, marine and aviation industries. Capacitors and batteries are both stored energy. While batteries release energy gradually, capacitors discharge it quickly. Which is the capacitance value to the capacitor is measured in farads. Unit name for the English physicist Michael Faraday. Farad is a large quantity of capacitance. Most household electrical devices include capacitors that produce only fractions of farad, often 1,000 of farads, or as small as the picofarad. A supercapacitors, meanwhile, can store a very large electrical charges of thousands of farad.
Observation. A capacitor is a device that consists of two conductors separated by an insulator whose purpose is to store both electrical energy and charge. The more voltage or electrical pressure you apply to the capacitor, the more charge is forced in the capacitor. If a voltage is applied to the capacitor and then disconnected, the charge that is stored in the capacitor remains until the capacitor is discharged in some way. The capacitance of a capacitor is affected by the area of plates, the distance between the plates, and the ability of the dielectric to support electrostatic forces. In trial 1, we observed that as we increase the area of plate with a constant distance of separation, the value of capacitance also increases. This proves that the area of plate is directly proportional to the value of the capacitance. In trial 2, we observed that as we increase the distance of separation with a constant area of plate, the value of plate also decreases.
The capacitance is greater when there is a narrower separation between conductors and when the conductors have a larger surface area. If a voltage is applied to a capacitor and then disconnected, the charge that is stored in the capacitor remains until the capacitor is discharged in some way. An electric field then exists between the plates, which allow the capacitor to store energy. This is one of the useful aspects of capacitors, the ability to store energy in an electric field so that can be utilized later on. The surface area of the plates and the spacing between them determines the amount of charge that may be stored per volt applied. The larger the plates and the more closely they are spaced, the more charge can be stored for every volt of potential difference between the plates. The charge stored per volt applied is the capacitance, measured in farads. Presently, for the analysis, capacitance is directly proportional to the electrostatic force field between the plates. This field is stronger when the plates are closer together. Therefore, as the distance between the plates decreases, capacitance increases.
Conclusion. Straight off for the conclusion, in this experiment we have verified that the capacitor depends on the plate size and the distance between the two parallel plates of the capacitor. In addition, this experiment is about calculating the value of capacitors. The amount of charge needed to produce the potential difference in the capacitors depends on the area of the plate, distance between the plates, and non-conducting materials between the plates. The results are verifying the theory which states that when the area of the plate is increased, the capacitance is increased. That shows the area of the plate is directly proportional to the value of the capacitance. Based on the result of the trial, we conclude that the increasing plate area would increase the charge and consequently also the capacitance of the parallel plate capacitor. Meanwhile, increasing the distance of the separation would increase the voltage due to the increased resistance, which would consequently also the capacitance of the parallel plate capacitor.
깊은 바닷속에선 널 데리러 왔어. 어째 나는 잊어버려. 우린 함께할 네 모습이 보여. Well, everything 보여. Would you like to swim in the sky? 우리 멀리 떠나자. Cause baby 너 여기 밖은 좋아. Swimming, swimming, swimming like a bird. Dreaming, dreaming, I can fly to anywhere. You are, you are, that's right. Swimming, swimming, swimming like a bird. Say you want to, I can bring you to the moon. You'll come to watch me dancing just for you. 깊은 바다 속에선 널 데리러 왔어. 어째 너는 이제 버려. 우린 함께야. 네 모습이 보여. Will everything 보여. 우리 멀리 떠나자. 'Cause baby 너 여기밖엔 좋아. Swim